Cool. Finally, what are the domains of these functions? F of x equals log base 7, negative x plus 2. Remember, the idea we had was log base a of stuff. Then this stuff here must always be positive. So it must be positive. Otherwise, it just doesn't work. Right? If we try to take the log of 0, doesn't work. We tried to take the log of a negative number, doesn't work. So you always have to take the log of positive numbers, whatever the base is. For any base, this is going to be the case. So it doesn't matter if it's base 7 or base 50 billion. It's going to be the case that we have to have whatever's inside of the logarithm, whatever the logarithm is operating upon, has to be greater than 0, has to be a positive number. So we know the thing that log is operating on here is negative x plus 2. So we know that negative x plus 2 must be positive. It must be greater than 0. We move the x over. We have 2 has to be greater than x. So x has to be less than 2. And it can go all the way down to negative infinity because the only restriction we have is 2 is greater than x, which we could write out as anywhere from negative infinity up until positive 2, but not including the positive 2, which we show with a parenthesis to show not inclusive. Over here, g of t equals 5t times log base pi, 3t plus 7. Once again, the base doesn't really matter. It has to be positive no matter what the base is. For any arbitrary base a, it has to be positive on what the logarithm is operating on. We look at the 5t part, we might get worried, oh, is the 5t going to interact with it? 5t times log pi, 5t is really in its own world. It's doing its own thing. 5 times t, we can do that for any number. We can multiply 5 times any number, so its domain is anything at all. It's not going to actually get in our way. Once again, the only thing we're worried about is when is the logarithm going to try to take the log of a negative or 0 number. So that must, to avoid that, we have to have that 3t plus 7 must be greater than 0. Otherwise, we'll be taking a log of something that we cannot take logs of. That would break our function. So 3t plus 7 is greater than 0. Subtract by 7. 3t is greater than negative 7. Divide by 3. T must be greater than negative 7/3. So t starts at negative 7/3, but not actually is able to include negative 7/3. So it starts just above negative 7/3 and can go anywhere larger, so it can go all the way out to positive infinity. So we've got negative 7/3 shown with a parenthesis because we can't actually include negative 7/3. We can just get arbitrarily close to it, going all the way out to positive infinity. And there are our 2 domains. All right, cool. We'll talk a bunch more about logarithms in the next one, where we'll explore the properties of logarithms, and then we'll see even more about how the 2 connect. We've got a lot of really interesting ideas. It's new stuff, but once you start practicing it, as you do it a bunch of times, logarithms will really start to click in. You'll get this idea of what am I trying to raise this number to get the thing I'm taking the logarithm? What does this base have to be raised to get the number that I'm taking the log of? All right, we'll see you at Educator.com later. Bye.